All right, this is the Building Outdoor Communities Outdoor Economic Impact Toolkit video, number 7, number 8. I'm losing track, but we're getting towards the end. This might be the last one. So your narrator is John Whitehead, and our text is Recreation Economic Decisions by Loomis and Walsh. And we have been marching through this book. We've measured quantity, measured price, talking about recreation demand, and the travel cost method for estimating the benefits of recreation demand, the contingent valuation method for estimating the benefits of recreation demand, and benefit transfer and other methods when you don't have the time or money to do a travel cost or a contingent valuation study. So now we're going to take those benefit estimates, those consumer surplus estimates, and see how they're used in benefit cost analysis. Okay, we're in chapter 19 of the book, and I'm going to be covering pages 369 to 375 and 379 to 389. Okay, so to begin with, in terms of comparing benefits and cost of recreation programs and infrastructure, it's important to keep in mind that we're analyzing public decisions. So we're thinking about gains and losses to society and not just revenues and out-of-pocket costs. So revenues and out-of-pocket cost is what is used in a financial analysis. So we're doing a benefit cost analysis where the benefits of outdoor recreation are these consumer surplus of benefits. Okay, people's willingness to pay over and above the amount of money they spend on the recreation activity. And then the cost are any monetary expenses plus opportunity costs, where opportunity cost is the next best alternative use of maybe the land that's set aside for recreation or something else. Okay. In terms of, the book goes through a little bit of the theory of benefit cost analysis, okay, with this figure 19.1. And I'm just going to pull out this upper left panel and we'll take a look at it. So conceptually, you might think that we're trying to estimate the biggest difference between the total benefit, this upper curve, and the total cost, this lower curve. And the quantity that we're measuring is recreation days per year. And on the vertical axis is a dollar amount. Okay, so between B and C is the maximum net benefit. Okay, so a lot of times a benefit cost analysis can look at different sizes of projects, and that's what's going on in panel 2A with the campground size. You can estimate benefits above cost for level D, A, and G, or for D and A, and level A has maximum net benefits. And then you can compare that to level G, where the net benefits are 0 because the benefit and cost curves intersect. And then level K is when the total cost is greater than the total benefit. So what we're trying to do with benefit cost analysis is try to identify projects that generate maximum net benefits, like project A here. Okay, and one thing about recreation projects is that the benefits and cost have different patterns over time. Okay, so this graph in figure 19.2 illustrates what a typical project might look like. On the horizontal axis, we're measuring this in years, and the cost might be large in the beginning when the project is being constructed or getting off the ground, and then those fall, and we might have operation and maintenance costs that are fairly low and constant over time. And the benefits might grow over time. So here we have some recreation infrastructure that people start trying out, and there's low benefits, low visitation in the beginning, but as word gets out and people become accustomed to the new facility and gain experience, then people take more and more trips and benefits increase over time. Okay, so the way to compare benefits and costs at different time periods is with this concept of discounting, and we're going to try to calculate the net present value of the time paths of these benefits and costs. Okay, so let's first just define what discounting is. And so this first equation is a present value. This is the current value of some future payment or a future cost, and that's what the future value is. Okay, so to obtain the present value, you take the future value, future dollar value, and divide that by 1 plus the interest rate or the discount rate R raised to the power of t. Now we could go through a bunch of equations to show that that's the case, but I'll trust y'all to take a look at the book, and if that doesn't do it, I can certainly provide additional readings about how this formula works and why it works, but it's the inverse or the opposite of the compounding interest formula. So it's based on that principle. Okay, so here's an example. Let's say that someone is going to give us $100 2 years from now. And if the discount rate or the interest rate is 10%, then the present value of that $100 received 2 years from now is about $83. So 100 divided by 1 plus 0.10 raised to the 2nd power or squared is equal to 82. So the concept of discounting is that money received or spent in the future is worth less today than if the same dollar amount is received or spent today. Okay, so that's how we can compare different dollar values over time. Okay, so with that, so we have talked about how to estimate consumer surplus and recreation benefits. In general, the biggest cost, a lot of times the biggest cost of local recreation is monetary, or the dollar cost of construction. So with that information, there are two ways of comparing benefits and cost. Okay, and the first is with the benefit cost ratio, and this is what the formula looks like on the right. Okay, the benefit cost ratio, the benefits are in the numerator and the costs are in the denominator. Okay, so in this numerator we've taken the present value formula, and instead of a future value we've substituted that for benefits, B. And then here with this summation sign we're just adding up benefits over time. In terms of cost, here we have K, which might be an initial construction cost that is not subject to discounting in the future. And here we have future construction cost or operation and maintenance cost. Okay, so the idea with the benefit cost ratio is if the ratio is greater than 1, then the project is a good idea. It adds more benefits to society than it adds cost to society. Okay, so we'd say that that project is worthwhile economically. If the ratio is less than 1, then the opposite would be true. That would be a project we don't want to pursue. Okay, so then another way to express this same information is with a net benefit formula, or let's call this the net present value, which is a term we used earlier. So here we have the same calculations. We have the present value of benefits and the present value of costs. And so if you take the present value of benefits and subtract the present value of costs from that, you get the net benefit or the net present value. In this case, if the net benefits are greater than 0, the project adds more benefits to society than cost, and the public expenditures are worthwhile. But if the net benefits are less than 0, the project adds more cost to society than benefits, and we'd say the project is a bad idea. Okay, so if you are interested at all in an example, here is a benefit cost analysis of the Middle Fork Greenway Trail. This is a local project that myself and John Lehman and Melissa Weddle worked on, and we had a little report and we wrote it up as a full-blown benefit cost analysis, and I think it's a decent example of how one works. Okay, and this is benefit cost analysis when the Middle Fork Greenway Trail connecting Blowing Rock and Boone was just someone's crazy idea. And I think back then we're going to add 6.5 miles between those two places, and I think the current mileage is like 9 or 10 that they're working on. So if you go to this website down below, you get to this web page that tells you it's a working paper from the Department of Economics at App State. And then if you click on this download, you'll get a PDF of the short paper, and you get an example of a benefit cost analysis that has a pattern of cost and benefits that look like this. And there is also opportunity cost built into that in terms of the opportunity cost of the land that's being used for the greenway. And so you can see how opportunity cost might factor into a benefit cost analysis.